Face the crucifix. The crucifix is that away. Thank you. Let's pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thine intercession, was left unaided. Inspired by this confidence, I fly unto thee, O Virgin of Virgins, my Mother. To thee do I come, before thee I stand, sinful and sorrowful. O Mother of the Word incarnate, despise not my petitions, but in thy mercy hear and answer me. Amen. In the name of the Father, of the Son, and of the Holy Spirit. Yeah, for those of you who are listening at home, hi Juliet. We will be checking off. Gentlemen, have a seat. Michael, chair. Thank you. We are finally going to check off the worksheet that would not die. 5E-4.
There's a baseball player.
I was like so surprised. I heard about it before, but then I thought, oh my
What?
gosh.
How was, what? You mean you're gonna be there in a week too? I'm gonna stay with you. I'm staying in the same class.
I like check.
That's so boring. Wait, I have this.
Yes.
Are you checking
And
out
5E-5, I give everybody a 3 on that one. That was an in-class drill. So that was for your, I did give you points, but that was mainly for your practice. So, the more you did on it, 5E-5, I gave everybody credit for. I gave you points. That was just an in-class practice. So, okay. Yeah.
Yeah. They always make jokes.
5E-5 is the one you have. If you just fab, I don't need it. I give her.
That is so gross.
That is disgusting.
No, it's not husband. It's like this is the main guy of that
There's
show.
some other teachers too.
Yes, like they're always like the guys that he invites on. Always make fun of.
Miss Harris. No, the
All right.
fourth grade teacher with the class. Here as well.
Base press. 4 on the floor. Thank you. Thank you. What are you doing? I'm staring right at you. All right. Let me read off the answers one last time. Some of these I already did, but I'm going to read them all just to be safe. Number 1. Whole bunch of stuff. First, velocity is negative 2t plus 11. A of t is negative 2, no variables. When does it change direction? At t equals either 11 over 2 or 5.5. It's moving to the left from 11 over 2, comma, infinity. It's moving to the right from 0 to 11 over 2. Careful with the interval. There's a square bracket on 0, it includes it, and a round bracket on 11 over 2. It was already moving right when the experiment started. When is the acceleration 0? Never. Not during the positive time values. When is it slowing down? From 0 to 5.5, square bracket on 0, round bracket on 5.5 for 11 counts. When is it speeding up? Round bracket 11 over 2, comma, infinity. And it repeats on number 1. Number 2, velocity function is 3t squared minus 32t plus 64. Big. of t is 6t minus 32. Changes direction twice at 8/3 and at 8. T equals 8/3 and t equals 8. What's the problem? When is it moving left? From 8/3 to 8, round bracket, round bracket. When is it moving to the right? There are two intervals. From 0 to 8/3, square bracket on 0, round bracket on 8/3. And the other interval is from 8 to infinity, round brackets on both. That's when it's moving right. When is the acceleration 0? There's only once. T equals 16/3, also 5 1/3. When is it slowing down? Two time intervals. From 0 to 8/3, square bracket 0, round bracket 8/3. And also from 16/3 to 8, round bracket, round bracket. Can you read it so far?
That was slowing down.
That was slowing down, correct. When is it speeding up? There are two intervals. From 8/3 to 16/3, round brackets on both. And from 8 to infinity, round brackets on both. Any repeats on 1 or 2?
For number 1, can you repeat when it changes direction and the left interval?
Yes, changes direction at t equals 11/2.
Okay.
And what interval, I'm sorry?
The left interval.
What do you mean by
When
left
it's
interval?
moving left.
Oh, gotcha. Okay. It should be from 11/2 to infinity, round bracket, round bracket.
Okay, thank you.
No problem. Do it again. Move on to number 3. The acceleration is 12t squared minus 78t. It changes direction at t equals 39/4. You could also do 9 3/4 or 9.75 if you must. When is it moving left? There's one interval. From 0 to 39/4, round bracket, round bracket. When is it moving to the right? From 39/4 to infinity, round bracket, round bracket. When is the acceleration equal to 0? Twice, at t equals 0 and at t equals 13/2. You could also do 6.5. When's it slowing down? One interval, from 13/2 to 39/4, round, round. When is it speeding up? There are two intervals, from 0 to 13/2, round for both, and from 39/4 to infinity, round for both. And it repeats on number 3. Number 4, a of t is equal to -12t squared plus 60t. Changes direction at t equals 15/2, or 7.5 if you like. It's moving to the left from 15/2 to infinity, round brackets and both. Moving to the right from 0 to 15/2, round brackets and both. There are two times the acceleration is 0. T equals 0, t equals 5. So I can grab a lot. When is it slowing down? From 5 to 15/2. I think this is the one we did in class. Round brackets on both. When is it speeding up? Twice. From 0 to 5, round brackets on both. And from 15/2 to infinity, round brackets on both. And it repeats up to number 4. All right, number 5. They gave you s of t. The maximum speed is 196, and it happens at t equals 14. The displacement is 160, 160. And the distance traveled is a funky fraction. If you didn't get the fraction, I'll give you the decimal, but I'll give you the fraction too. The distance traveled is roughly 653.037. The fraction is 5 digits on top, so beware. 17,632 on top, 17632 over 27. I will show you today how to get that on the calculator. Number 6, maximum speed is 75, and it happens at t equals 10. Displacement is -308, and the distance traveled is 340. And it repeats on the whole thing.
What was the max speed for number 6?
Number 6, the maximum speed was 75, and it happened to T was 10. Any other reasons? Yeah.
Do you repeat the displacement for function number 5?
Displacement number 5, 160. Anything? Last call. All right, I've got about 10 minutes. We can go over a problem or two. We've gone over most of them, but I can go over anything that happens. And then we're launching into a new topic, which is arguably the last topic of the chapter. For planning purposes, I had thought that maybe we would have a test at the end of this week. That turns out not to be the case. Next week is kind of goofy. The Monday and Tuesday are off. It's for winter break. And so it's just Wednesday, Thursday, Friday. I think I'm targeting the Friday of that week as the next chapter test. Now, if there's like a billion other tests hitting at once, please let me know so I can move Armageddon a day earlier. We'll see what happens. That came out wrong. I meant Armageddon. I didn't mean this test is going to be Armageddon. It's going to be fine. You know what I mean. Any other questions? Yeah. Yeah, okay. Yeah. Any other math questions on 1 through 6? Everybody feeling relatively confident in doing a problem like this? Yeah.
Can we do number 2?
Number 2. Yeah.
Let me grab a marker.
It's similar to number 1, so I'm going to, assuming B of t and A of t are okay. Jonah, were there particular ones you wanted to go over? I assume finding B of t and A of t are okay.
Yeah, that is
Okay.
totally fine. And I think I know how to do these. Can we just go over like left,
We can
right,
pretty much
slowing
go
down,
anything else. How about change in direction? Is that okay? Yeah.
Sorry.
I'd change in direction.
So, yeah, change in direction and like slowing down and speed.
Okay. I need everybody's focus, even if you got this problem right. Number 2, how do you find a change in direction? Easiest way, plus minus notation. But on what? Which formula? Yeah,
Velocity.
velocity. If the velocity changes from positive to negative, that's a dead giveaway of change in direction. So velocity, this is number 2. The velocity function is 3t squared minus 32t plus 64. And I need to set that equal to 0 in order to get the breakpoints. There are no vertical asymptotes, there are no holes because we're not dividing by anything. But let's see if this thing actually solves. What's your favorite method for solving this thing? You could hope it factors, can't do algebra. You could do complete the square, could do quadratic formula. What do you think?
I did magic pair.
Okay, did it work?
Yes.
Good. So I'm going to circle the first and last. This is 192 t squared. What was the magic pair?
Negative 8t and negative 24t. Sorry, just 8t, not 18.
18.
Yeah.
And negative what?
Sorry, just 8.
Oh, 8t.
Sorry.
Sorry. We're good. And negative 24?
Yes.
So negative 8t, negative 24t?
Mhm.
Okay, got it. So those definitely add up to negative 32, and those do multiply to be 192. Good. Plug these in. 3t squared plus negative 8t plus negative 24t plus 64 equals 0. It's factored by grouping. I'm going to kind of turbo this. I'm going to pull out a t, 3t minus 8, plus negative 4. Wait a minute.
Negative
8. Thank you. Negative 8, and this will be 3t minus 8. And that does work. Pull these out. So 3t minus 8 and t minus 8 equals 0. So we have two solutions of t is equal to 8/3 and t is equal to 8. Single, double, triple?
Single.
Single, correct. So I'm going to mark these. By the way, 8/3 is like 2 2/3. So it's to the left of 8. So 8/3 and 8. Single root, single root. They're not really roots, but they're roots of this thing. So we've got 3 regions, A, B, C. What did you test for Or what do you want to test? What?
1,
Sure. Or interestingly enough, you could do what?
0.
You could do 0 if you wanted, totally up to you.
Well, we can do 0 then.
Sure.
Um,
I have no emotional attachment. If t is equal to 0, what's v of t? Probably easiest up here.
no, positive.
V is positive. It's positive 64. What's this?
Negative.
How about this?
Positive.
Good. Did it change direction anywhere? Yeah. How many times?
Twice.
Twice. It went from positive to negative and from negative to positive. So a change in direction at 8/3 and a change in direction at 8. This will also answer when it's moving left and when it's moving right. It's moving left when the velocity is negative, from 8/3 to 8. Why do I not include 8/3? Why is it round bracket? Because they had round bracket. Why not square? Go ahead.
Because it's moving that way. That's moving.
Right. It's just staying put. It's not moving left. It's that very instant when it stops moving right and starts moving left. That very instant is not moving at all. So it's round bracket 8/3, round bracket 8. Does that make sense? And moving right would be from, why not negative infinity to 8/3? I didn't read that. It was something else. Michael. What two intervals is it moving to the right?
You don't wanna count the infinities.
Well, it depends.
Well, if we are, then it's negative infinity, count the 8/3.
And what was the other one?
Union 8, count.
I would say one of those infinities allowed and one of them is not. Which is which? Max?
So negative infinity.
Why? You're right. There's something in the problem itself.
Does it not, sorry, does it not, there's a lot of those things where it's not asking for that?
You're thinking of roots and those if they're not asking for roots, so like if it's greater than 0. This is a little different. It's definitely not asking for negative infinity, but why not? What in the instructions says not to use that? Jack?
Oh, it's t is greater than or equal to 0.
Right,
So you
they
start
started the
at 0.
experiment at 0. So in other words, you've got to put a 0 here as a cutoff point. So from 0 to 8/3, it's moving to the right. It was moving to the right before 0, but our experiment started at 0. So whoever got to the lab early and was just running the experiment for fun would have had positive, 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 positive. But when we started it, it was already moving to the right. And we're not counting anything below 0. Does that make sense? I am counting everything from 8 to infinity, because you can run the experiment forever if you want, but you just can't go back in time. Does that make sense? All right, so acceleration, when is that equal to 0? You tell me. Holly, how do you find when acceleration is 0?
Number 2.
I'm sorry?
For number 2.
Yes. Like, how do you do it? One step. They want to know when the acceleration was 0.
Was that equal to 0?
Right, just take the acceleration and set it equal to 0. And you should get 32 over 6, which reduces to 16 over 3. So when is it slowing down? It kind of depends. This is the v of t plus minus notation. I want to do the a of t plus minus notation. And the formula for a of t is just 16 minus 32. There's only one breakpoint at 16/3, or 32 over 6. If you test 0 in this thing, you're going to come up negative. So the acceleration is negative, and then this is positive. Can somebody translate what that means? What does this mean in the real world? What's going on?
It's slowing down.
Maybe. This is acceleration. So what does acceleration do? What sort of thing is it? If something is trying to accelerate you, what is it doing? Anyway, what is an acceleration in physics? Like what would you expect to happen if here's this marker just floating in the middle of Lake Michigan or something, and then an acceleration is acting on it? What do you expect to happen?
Speeds up.
Starts to move. It's trying to speed something up. So it's a pull or a push. It's a force. So if I start pulling it to the right, it should start accelerating to the right, unless it was already moving. All an acceleration is a pull. It's a gravitational pull, if you will. This is pulling to the left. And then here is pulling to the right. Where is it actually moving? Depends on how fast it was going and which way. In other words, if this marker is torpedoing, if somebody shot it out of a gun and it's going 1,000 miles an hour to the right, and all of a sudden an acceleration starts pulling to the left, is this thing going to stop instantly? No, but what's it going to do? It's going 1,000 miles an hour, it just got shot, the gunpowder is long gone. It's just, let's assume there's no air resistance. Let's assume there's no air and everybody's suffocating. Physics does it all the time. Now, it's going this 1,000 miles an hour. All of a sudden, an acceleration starts pulling this way. What's going to happen to this thing?
Slows down.
It's going to slow down. If it's already moving to the right and it pulls to the left, it'll slow down. Anytime velocity and acceleration are going in opposite directions, it's going to slow down. Anytime they're going the same direction, it's going to speed up. Does that make sense? So here, and 16/3 is 5 1/3. And this, by the way, is 2 2/3. So tell me what's happening from 0 to 8/3. As far as, is it speeding up or slowing down? If it helps, let me put the velocity on top and the acceleration on the bottom. Here's 0, that's going to be true for both. That's just the cutoff. The first event that happens is at 2 2/3. I'll even mark it as 2 2/3. That's when the velocity is positive, but stops being positive. And then way over here at 8, it stops going to the left and starts going to the right again. Now on the bottom, the acceleration changes at 5 1/3. It's like kind of here. The acceleration was this, and then this. Does that kind of make a little more sense? Compare the two and tell me, can somebody give me an interval? Like what's happening, I'm just gonna break this up. From 0 to 2 2/3, is it speeding up or slowing down? Yeah,
Slowing down.
it's slowing down. Why do you say that?
Because it's going to the right, but it's being pulled towards the left.
Right. It's going to the right, but the acceleration is going the opposite direction. It's fighting it. Now, what is happening from 2 2/3 to 5 1/3? No.
It's speeding up
Speeding up. Why?
because it's going to the left.
Going to the
So
left?
It's being pulled to the left.
And it's being pulled to the left. So they're joining forces and going faster, faster, faster. Max, what's happening from 5 1/3 to 8?
It's slowing down.
Why?
Because
Yes.
it's, going to the left, but it's being pulled to the right.
Correct. And then, Julius Ishan, when it's after 8 seconds, what's it doing?
Speeding up.
Speeding up. Explain.
It's going to the right and it's accelerating to the right.
Right, it's going to the right and it's accelerating to the right, it's being pulled to the right. Does that make sense? All right, is there anything else on that problem? That was it. Good to go. Well done. Any other questions? Yeah,
Can we go over the maximum speed, number 6?
number 6, yeah, max speed. The maximum speed, now there is no formula for speed, except it's the absolute value of velocity. We'll need to find the velocity function first. So S of t is t cubed, blah, blah, blah. So number 6, the velocity function, just take the first derivative, it'll be 3t squared minus 60t plus 225 HCF of 3, by the way. This is t squared minus 20t plus 75. So, they're asking for the maximum speed. When would that occur? 2 possible times. Maximum speed, there is no formula for speed other than the absolute value of this. And we've never taken the absolute value function and done a derivative or an integral on anything yet. You don't have to. Quick example, I've done this before. Let's just say this little missile here is going to the left at 300 miles per hour. That gets its maximum, like that's the fastest it goes to the left. And then later it's going to the right at 500 miles per hour. So 300 miles per hour, 500 miles per hour. What's the maximum speed? Go. 500. Prove it.
The absolute value of negative 300 is just 300.
Right, the absolute value of negative 300 wasn't good enough. It was positive 300. Now let me flip it around. Pete, going left, 1,000 miles an hour. Going right, 800 miles an hour. What's the maximum speed? 1,000. Explain. Right. In other words, there are a bunch of velocities. I gave you the maximum negative, quote unquote, the biggest looking negative and the biggest looking positive, which we call the minimum and maximum velocity. So how do you find maximum speed? It's at one of 2 places. Either the maximum velocity or the minimum velocity. Does that make sense? Because you have to take the absolute value. If you have a bunch of velocities and the lowest ever goes is negative 2,000, and you have a bunch of velocities and the maximum is 1,000, the top speed is 2,000, because we take the absolute value of both. You don't have to check the billions of other values of t. All you have to do is check the maximum velocity and the minimum. This is velocity. To find the max or min, you set the velocity equal to 0. Solve. Does it factor? I don't think it does, actually. Hang on a second. Wait a minute, 15, 15, yeah, it does. T minus 15, T minus 5. That's a bonus. So it unfoils. Give me the 2 values. Ollie, help me out. What 2 values of t are we looking at?
15 and 5.
T equals 15 and t equals 5. By the way, if I had gotten a time value that was less than 0, I'd have to throw it away because we're not counting those in these physics problems. Now, I don't know what the speeds are there. I don't know what the velocities are there. So, Michael, take over. I've got 2 time values. Why not, what do you get when you take velocity set it equal to 0? What's the purpose of that? Actually, okay, oh, I just made a mistake here. I gotta correct it in just a second. Go ahead.
Time when it just switches directions.
Yeah, those are the times when it switches directions. Would this give us, here's where I have to show off my error. Would these give you max and min velocities? No, it would give you max and min original function positions. So how do you find maximum? It's morning, it's Monday. It's Monday morning. How do you find maximum velocity?
You set the acceleration function.
Set the acceleration equal to 0. So that was lovely factoring and such. That would have been precious, but it's wrong. So I will own that. I will hang my head in ritual shame for 2.5 seconds. 6t minus 60. We've got 1 value. If you set this equal to 0, t equals 10. That's the only possible time. What's the velocity at that point? Speed.
Ooh. The velocity at t equals 10.
Correct. How do you find it?
Would you just plug it into the velocity?
Exactly. Go ahead and plug this in. What do you got?
300.
300
Negative 600.
minus 600.
2,200.
There's no t.
Oh.
So 225. Add them up. What's 300 minus 600? Negative 300 plus 225? Negative 75. The velocity is negative 75 at this point. So what's the maximum speed? 75. And when did that happen?
At t equals 10.
Exactly. At t equals 10. Does that make sense? All right. Any other questions? Last call. All right. You got your notes, please. I want to show you a new concept. Historically speaking, physics is a little more in the abstract intense part because you really have to kind of picture what's going on. This part, depending on how your brain is wired, most people find this to be a welcome change. It's relatively intuitive. It's just mathematically tedious. Have your calculator handy, you will need it. Allow me to introduce you, notebooks out please, a Riemann sum. Riemann was a mathematician who lived back in the 1600s, I think. Something thereabouts.
Is he where the word sum comes from?
Oh, what's that?
Is he where the word sum?
Oh no, they had the word sum for quite a long time before you showed up. But a Riemann sum is a particular type of sum. A sum is like adding up things. And then Riemann was faced with this problem. This is,
I thought his last name was sum.
oh no.
I thought that was just the guy's
Oh
name.
no, the Riemann was the guy's last name. I don't remember his first name. That's a good question, sorry.
Oh my gosh, I'm such an idiot.
No, you're good.
Got it on video and everything.
It's approximation method for area under the curve. Of a function. We've dealt with area under the curve of a function before. It's the antiderivative, it's the integral, with boundaries, and it can calculate the area under a curve. It's not actually not all that hard. But sometimes we've run into problems where taking the integral, taking the antiderivative, is hard. It's a beast. Integration by parts is tedious. Integration by substitution sometimes doesn't work. This is used whenever the antiderivative is so horrendous it would take you hours to do it, or it's impossible. In other words, a time where you just don't have the time, or it's just not possible to do an antiderivative and get the real exact area under curve. This is a way to get an approximation. Let me give you an example. We did this kind of, sort of, about a month ago. Draw the following. Y equals radical x. And I want to limit it to the interval from 1 to 4. Go ahead and write that down. I want the area under the curve. I want the approximate area under the curve. This one actually does have a nice antiderivative, so we could theoretically get the exact answer. But right now I want to practice the skill. First we need to graph this thing. Can somebody talk me through that? We graph radical x. Where do you start? Matt, tell me out. How do you graph this thing? I don't need the derivative. I'm just graphing it, like first year algebra. Graph it.
I don't.
Okay, Michael.
You want to get it in front of
That's for derivatives.
Well,
Pretend you're in first year algebra again. How do you graph y equals radical x?
Get the radical out of the.
It's not in the denominator.
Let's see,
Please.
Start at, I don't know, 0.
Yes. Why not start at -1?
Because that's just where the graph is like truncated, there's still like part of the graph is.
True. First of all, it's truncated. We didn't include 0 because of that reason. There's another reason not to include -1. Yeah.
Well, if you plug in for x, it's imaginary.
Yeah, if you plug in -1, it's imaginary. There is no graph to the left of 0. The starting point is 0, 0. For those of you who need to dust this off, whenever you get stuck on a function graph, make a table, XY chart. This is, by the way, one of the parent graphs from second year algebra and pre-calc, so it should be relatively familiar. Over 1, up 1. Over 4, up 2. It's a sideways parabola, the upper part. I'm going to make this dotted. So here, from here to here, I want the approximate area under the curve from here to here. The area of that section, down to the x-axis. Don't go forever. That would be infinite. Well, these are easy. Infinite, infinite, infinite. No, they stop at 0. They stop at the x-axis. So this interval and this in between those, what's the area? I can't use regular geometry for this because this is curving and it's not a circle. So it's nothing that no formula I know of can find this. But Riemann said, and I gave you a hint on this before, there are ways to approximate it using shapes that we do know. And the easier, the better. There are horrendous shapes you can use, but the easiest thing what do you think is the easiest thing to calculate the area of? Jack?
Square.
Square or rectangle, same difference, base times height. I agree. If we can cut this into rectangles, that would be a reasonable approximation. There are 5 types of Riemann sum. Technically, the 5th was not designed by Riemann, it was designed by somebody else, but it's categorized as Riemann because Riemann is sort of the father of this. There are 5 types. You'll have to know how to do all 5 of these. The first is called an upper sum. The second is called a lower sum. By the way, I will say in some books, I can hear you. Please hold your conversation. I'm still hearing you, honestly. In some books, these are called the left sum and the right sum instead. Now, upper sum and left sum are 2 different things. I'll show you what these are in a minute. But the third one, actually I'll leave that blank for a second. Let me show you what an upper sum is. An upper sum, before we start, there's a code for this. N equals, please write this down, the number of slices, the number of rectangular slices. N is going to represent the number of slices that we use for approximation. The easiest sum to do is 1 slice. Let me just give an example. Let's assume that n is equal to 1. So we're just going to use 1 slice. An upper sum, see this height is 1 and this height is 2. I want to fit a rectangle over this. But I want to use an upper, now, do you see that if a rectangle would not fit perfectly? I've either got to fit it to the top one or fit it to the bottom one. The upper sum is when you fit it to the top one, the upper one. The lower sum is if you fit it to the bottom one. So here's an upper sum. I'm going to do this dotted line thing. this thing, I think it'll do US for upper sum. Can anybody give me the area of that rectangle? How wide is it? Michael, help me out. Yeah, and by rectangle, I mean this entire thing. Let me see visually what I'm talking about. So what's the width?
4,
Okay, well,
3.
3. What's the height?
It's huge.
What's the area?
8,
It's base times height, so it's 3 times 2, which is what?
6.
Thank you.
Sorry.
The upper sum is 6. That's our approximation, we're done. Can somebody give me a lower sum? A lower sum would, if you use a rectangle with the lower of the two heights. Jack, do that one for me.
It's 3.
Tell me how. Yeah, so base is 3, height is 1, so the area is 3. Neither of those are right. The upper sum is too big, the lower sum is too small. Does everybody see visually that's going on? Can anybody find a possible way to do better? Can you get a better estimate than those? Gentlemen, I really would appreciate you not joking around and focusing on the lesson. Okay? Yeah, good.
The average of
You can
the
take the average of them. Geometry people. When you take the average of an upper rectangle and a lower rectangle, it creates a new shape. It's hard to picture, but does anybody know what shape you'd cause? You'd actually get a rectangle that's exactly halfway, but it's the area of something else. I'm curious if anybody remembers this formula from geometry. The area is, take the average of the two bases times height. What shape is that? Base times height is a rectangle or parallelogram. If you average the bases and take the height, this is the area of something called a trapezoid. A trapezoid looks like this, again. So here's base 1, base 2. If I try and get the area, base 1 is too small, oops, base 2 is too big, but the middle base is just right for you Goldilocks fans. This is base 1 plus base 2 divided by 2. It's the average base. And then you multiply it by the height, you get your area. Does that make sense? The third type is called the trapezoid sum. It's actually pretty easy to get. It's the upper sum plus the lower sum divided by 2. Take the two previous answers and average them. You will get a trapezoid. So, and it looks like this. That's actually much, much closer. There's much less wasted space. Does everybody see that the trapezoid sum is still a little bit low? If you take the trapezoid, it's a little bit underneath the curve. There's this teeny little like orange, like mandarin orange slice here that's still wasted. Question?
Does that say US plus LS?
LS, yeah, it's supposed to be L. Right. US plus LS. Upper sum, this is upper sum and lower sum. So average those two. There is a fourth, which is a little more involved. It's called the midpoint sum. I'm gonna have to redraw the pictures to know what's going on here. Well, actually, I think I can probably do it. Can anybody, you see the two boundaries as 1 and 4? Like, the beginning is 1 and the end is 4. Can somebody tell me the midway point? Just off the top of your head. What's halfway between 1 and 4? Oh, okay.
2.5.
2.5. This is what I'm going to call the midpoint. It's 1 plus 4 divided by 2. In other words, go halfway, and then somebody get, this is actually kind of sneaky. Go up to the actual curve. You ever see it'll eventually hit? And then make a rectangle there. That's what we call the midpoint sum. This is a trapezoid sum. The midpoint sum is go halfway through and find the real height. Use that as the height. That's the one where you probably need a calculator. It's a little annoying, because basically, well, let me do these. The midpoint sum, could somebody calculate that for me? Sorry, trapezoid first. Holly, how do you get the trapezoid sum again?
We're gonna do 6 plus 3, 9.
Right.
And then 4.5.
Yeah, divide by 2, so it's 9 divided by 2, or 4.5. So the area under the curve is pretty close to 4.5. Let's try a midpoint sum. The midpoint sum is the base, which is still free, times the height of that midpoint. How do you get the height at any given point? Like, for example, at x equals 2, can somebody give me the height? How do you do that? Where's that? Go.
You just plug it in.
Plug it in. Plug in, like say x equals 2, plug in the height. The height of this would be the square root of 2, 1.4 or something. If you plugged in 3, it'd be the square root of 3 for the height. How do you get the height here?
Plug in 2.5.
The square root of 2.5. Grab a calculator, do it. It's going to be approximately something. Approximately what? Okay. So 3 times the square root of 2.5, and then just period. What do you get? 4.74? Give me 4 decimal places.
4.7434.
Yes, 4.7434. That's the midpoint sum approximation. So it's looking as if the height is somewhere in the vicinity of 4.5, 4.6, 4.7. Have you read so far? I'm going to give you one more. This was not invented during Riemann's lifetime. The 5th one is called Simpson's rule. No relation to the TV show. Simpson's rule. The actual geometry behind this is quite complicated. Does everybody see that the upper sum, they just take a rectangle, the upper rectangle, and the lower sum, you take the lower rectangle. All of these, like 3 of them are rectangles. Upper sum, lower sum, and midpoint sum. Those are all rectangles. The only one that got a little different is the trapezoid sum. The slice is a trapezoid instead of a rectangle. Somebody, I'm not sure how Simpson thought of this. He was brilliant, and he had a lot of time in his hands, apparently. He said, I wonder what would happen if instead of taking a straight line, either across or diagonally, what if I used a slice of a parabola? This uses parabola slices. Again, the geometry behind this is kind of horrendous. But does it make sense that if you have, like, let's just say you have some weird function like this, and I want to get the area from, let's say, 3 to 7. The upper sum is going to be horrible. Here's the upper sum. The lower sum is going to be a little better, but not great. The trapezoid sum is going to look like this, which isn't all that good. Because if it does this sort of valley dip, that's actually going to be pretty bad. It's going to be worse than the lower sum. Normally the trapezoid sum is pretty good. Midpoint sum is going to be even worse. It tries the height here. It's going to waste a lot. Here's what Simpson came up with. How about you take some random parabola that happens to fit almost exactly and take the area under the curve. That would be stunningly close. Everybody in the math world is saying, yeah, that would be really great. How do you do it? He came up with it, yeah.
Wait, how would it be close but not exact?
Oh, it's not exact because this is not a parabola. If you zoom in, there's going to be a little bit of difference. This thing is gonna eventually start curving down, this is gonna start curving up, and there's a little bit of, gap there. Okay. So it's not perfect, but it's very, very good for curving things. Simpson's rule is very good for curving things. By the way, if this thing happened to be a parabola, the answer would be perfect, because it would fit perfectly. I mean, that's called being insanely lucky. How do you do Simpson's rule? I need to give you the formula here. The formula, you need to memorize it. So Simpson's rule is this. Look at all the other codes there. 2 parentheses ms plus, well actually, let me do this the long way. So ms plus, whoops, not right to save my line. ms plus ts divided by 3. So what is that? Now, enjoy the fact that this is a relatively short formula. That's how you get the slice of a parabola. Let me show you what I mean. If, let's just say you have this sort of parabola type slice thing. Does everybody see that there's going to be a low point in the parabola? I mean, it doesn't have to be, you can, but here's the way I remember it. Let's just say this is A and this is B, and this is somewhere in the middle. Does everybody see that a trapezoid sum would go across the top, because it makes a trapezoid? And then the midpoint sum is here. Picture this as being like this end is high, and the midpoint is dented in. If you had to take a guess, which one in the physical world, if you had to say like, you're putting something on here and making it bend and making it weight down, which one's heavier? The trapezoid sum or the midpoint sum? This is kind of silly to put it this way, but which one seems to be denting things in? The midpoint or the trapezoid? Which one's denting it? Okay. The midpoint. Exactly. The midpoint is what I call heavier. It's actually twice as heavy. So you use it twice. So you count it twice. By the way, we're taking the average of these 3. Normally I would take, because normally you'd figure, well, let's take the average of the trapezoid midpoint sum. That would be decent. That would be a better estimate than these alone. But Simpson found out that if you gave the midpoints twice as much weight, it's almost insanely accurate. So count the midpoint twice, and then midpoint, trapezoid, and there are 3 items, divide by 3. You're just taking the average of 3 things. This is called a weighted average, where you're weighting the midpoint twice as much. Just for giggles, let's find out what that is. Simpson's rule. Now, you'll need the calculator, and you'll have to type in this. Here's how I type it in. Parentheses. 2 times 3 times radical 2.5. In other words, you can write 2ms instead of ms plus ms. It takes less time. Plus the trapezoid sum 4.5, close parentheses, divided by 3. That should do it. Let me catch up with you. 2 times 3 times radical 2.5. And then plus 4.5 divided by 3. Oh, great. We're getting a bit. What do you get? What? 66227, blah, 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 blah. That is by far the most accurate. And by the way, if you're curious, I'll show you this later, tomorrow. There is no homework tomorrow. Rejoice, be glad, pass it. There will be homework for tomorrow due Wednesday. But for now, get familiar with these. That's what the next assignment's gonna be about. Okay? Please stand. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Alrighty. You all have a good day. Thank you. Have a good day, y'all. Stay warm. Who's messaging me?
Thanks, Scott.
Thank you. See you later. This is the Wi-Fi cuts out.
What? Or, so your gift should be a new one.
Bye, Julia.